Hello, my name is Garrett Hall, and my portion of this project was to do a brief description of the history of the steam engine as well as key components of a steam engine.
Hi, my name is Bailey Jenkins. I did the construction portion of the project.
Hi, I'm William Hopton. I will be talking about the prototype testing as well as issues that came up.
So to start out with a brief history of the steam engine, the steam engine was first introduced in the 1st century AD when Hero of Alexandria in ancient Egypt created a primitive steam-powered device, which was either powered by the sun or fire, and it was used to move objects or water. And later on, Thomas Savery created an engine that combined the use of expanding and condensing steam. And this engine was used widely throughout the mining industry to remove water from mines. And the steam engine throughout the 17th and 18th century just kept getting improved more and more, and it led the Industrial Revolution by powering factories, boats, transportation, and much more. Some key components of the steam engine include the boiler, which generates steam by heating the water, the cylinder, which houses the piston, which converts this steam's thermal energy into mechanical energy, the crankshaft and flywheel, the condenser, valves, and a steam chest.
Thank you, Garrett. Just as a brief reminder, I'll be talking about the construction portion of the project. So basically how it started was I went online, tried to find a good base of what a steam engine would be good for this project. I then looked up some good 3D prints that can be used with a air compressor instead of with actual steam. The build process was simple, but I had to kind of improvise on some portions of it. So basically how it went was finding a good super glue to use with some of the parts and finding the right little 3mm screws that had various lengths for it as well. So basically how it went was combining these two frames, combining the crank that spins the piston, putting the crankshaft through the crank, and connecting the flywheel to that. Also gluing together the hose barb up here to the top of the frame and the piston pivot, which is inside the piston, or the cylinder, my bad. And the issue I had up here was basically when I put in this screw up top, the piston pivot or cylinder pivot kept coming loose from the glue, and I kept having to redo it over and over. Another parts issue that came up was the lack of a certain spring that was recommended. So I basically had to improvise and use 2 washers plus a screw that was slightly shorter than what was recommended, but still able to be loose enough for the project to spin loosely. And that's basically all my portion of the project, so I will hand it over to Will.
Thank you, Bailey. So, in Bailey's section, he did mention a few of the different construction issues, but a construction issue that I will point out that what we didn't know is that the air compressor and its sort of layout led to a lot of testing problems. So, with the barb here, we thought that the air compressor might just simply have a tube that we could just slide over this and inject air. Unfortunately, it didn't. So that led to a huge testing issue, which we weren't able to address once we actually fully 3D printed this. And as well, Bailey mentioned, with the lack of the spring here, it also led to it getting stuck a couple times. And so when we began our testing, it did work, but the PSI was around 10 PSI, and there were a lot of times where it would simply just get stuck in this position right here. And not only is that due to the spring making it not really flow as smoothly, it also had to do with this shaft right here. It's a little not smooth. There's a lot of little malformations with the 3D print. So if this were sanded down, that would actually probably improve it a little bit better. But in that case, when we actually began testing it, it just got stuck either due to the spring or due to the shaft. So for future improvements that we definitely do in the future is getting the spring that actually connected here, because this would make this section just move better, and then definitely sanding down this shaft so that, you know, this whole section could move a lot better and wouldn't stutter as much. So for our project, that is going to be it. Thank you so much.